Welcome to the May 2025 Ambassador Call for Aurorasaurus, and we're very pleased to have Bea Gallardo-Lacourt and Jeremy Kazub here with us and talking about a recent paper about Steve, as well as other Steve things that you all have been up to that will be of interest. And yeah, I will let them say more about themselves to introduce themselves. But for yeah, I think I'll let you guys introduce yourselves since most people know you, but it'd be great. Um, who would be starting?
Um, I don't know. Hey, would you like? I guess I could start maybe because if it's I don't know, start with an observation and then go into what the observation led to, if that works for
I
you.
think that sounds perfect.
Okay, I'll share my screen then and we'll get started. Um, and please let me know if you can see it, okay? Uh,
It
okay,
looks perfect.
good. Um, yes, this is an exciting presentation and I look forward to like presenting in two parts is kind of really appropriate in a way because it's about citizen science and there's a person that did the observation, I guess, a citizen scientist, and then how it led to the analysis by the wonderful community of researchers and how kind of curiosity bridges that gap and everybody just saying, hey, I saw something strange, let's look into it more. So I think it's a really nice way to present. So this is about and babe, please feel free to correct me at all if I get anything inaccurate because I tend to get things inaccurate like names and things. But I'm just started by calling this the quiet time Steve observation. It's and my little half of the presentation would be from the participatory or citizen science perspective, and then I'll hand it off to you to talk about how that observation leads to perhaps new investigations from the research side, and then how those two work together. But first, I want to congratulate Liz on the EC50 award. Uh, the Explorers Club is a multidisciplinary society, and they give out, I think, an award to the 50 people that are very much contributing to interdisciplinary or multidisciplinary advancement in research and science and exploration. And I understand that you were present at the award and you got an award, and I just thought that was wonderful. And on
Thank
their
you. Yeah, I wouldn't be there in fancy parts of New York City without all of you. So I really appreciate all of the efforts. Yeah.
and on their webpage they have a quote from Dr. Elizabeth MacDonald, who says, "As an aurora is created by the relationship between the sun and the earth, and science is empowered by relationship building across fields." And maybe that's appropriate for this presentation because it's the relationship building between the observation and citizen scientists and the research community. So I thought it was a very timely quote that you had there. So thank you. My name's Jeremy. As some of you know, I have an engineering background. I currently live about 300 yards from the Atlantic Ocean in a place called Cow Bay, Nova Scotia. And I used to live in Edmonton, which was further north in a magnetic latitude way, and then Ottawa. And the observation we'll be talking about is in that yellow mark in the top left, Yellowknife. Even though I'm way down in Halifax, we still have some interesting observations. Here's one from October 10th last year of what we think is maybe a SAR arc looking south over the beach. And everybody in the small community of about 1,000 people showed up and they'd never seen the aurora before. That was their first time. And so we had the opportunity to explain what it was. And they had no idea being this far south. This was their first big show, and there was cheering all along the beach. And so it just shows how much the community can get engaged and be wowed by something like this. It was like going to a little rock concert. The whole parking lot of the beach was full, even though it was fall and after beach season. So it really brought everybody together. Um, On the left of my next three slides, there's a QR code link back to what the Arctics team was working on, the Aurora Field Guide and Handbook. And I'll refer back to them a few times, but I hope that can be shared, or people watching this recording will refer back to that pair of books, because I think they cover a lot of things that were maybe understood or not understood and not really written down, like the relationship between citizen science and research, about how to make observations as a aurora photographer that are useful for the scientific uh, advancement. So you take a picture, how does it end up, even if it's something incredibly new, if it doesn't have the right context associated with it, you can't really go from there. And it really covers ideas like that. So I'll refer to a few different sections of it. The little cartoon is from Poorly Drawn Lines, and it's the idea of, if you're not a scientist and you're contributing to something, and all of a sudden there's scientists asking you things about what you've seen, and you start to wonder, like, am I going to embarrass myself by being involved in this? I don't really know what's going on. Um, this is a big door that suddenly opens, and there's a lot of people on the other side that really know what's going on. They have years of context and understanding and acronyms and terminology, and you're just a person with a few photos of something you haven't seen before. Um, but on the other hand, if you just leave your curiosity and leave your image on the hard drive for years, and because you're kind of worried about sharing it and people saying, it's nothing, don't be silly, it's I don't know, it's a street light or something, right? Then you're going to miss out. So you have to take that risk of maybe not embarrassing yourself, but you have to voice your curiosity and voice your questions, no matter who you are, to end up in a good spot with collaboration in this context. In the old days of presentations, they used to say Webster's Dictionary defines citizen science as, but now you can ask ChatGPT to make a picture of terminology. And I think this is really great because it kind of captures, like, ChatGPT and all those large language models are trained on everything on the internet, which means it's a reflection of what we think of ourselves. So if you ask it what it thinks of something, you're really saying, what does the entire internet have as a archetype or a zeitgeist for citizen scientists? This is the best I could come up with. These people, at first I thought it was ridiculous that they had three hands and that they're looking out of one side of a binoculars, but now I'm realizing it's really appropriate, because there's a lot of things to juggle when you're observing the aurora. And you are looking both through the binoculars, like through your camera and at the back of your camera, but you're also trying to take time to look up at the sky and talk to people around you and help them set their cameras. And then are you writing stuff down? Are you somehow capturing it in a way that it can be linked up with all the other science data? The other thing I noted was it doesn't really differentiate between a citizen scientist terminal or a definition and a participatory research. It just changed the name on the clipboard, but the person is looking the same otherwise in terms of what they're up to. So maybe that's what the sort of general internet thinks about citizen science versus participatory research. Lots of things going on. It would be nice to have three hands sometimes when you're operating all the cameras and trying to capture everything. Uh, Going back to that field guide, it does define citizen science and citizen scientists. And it says, with their diverse geographic locations and dedication to observation, they provide a resource that would be difficult for professionals to gather alone. At the Arctics conversation, one of the researchers said, I've maybe only seen the aurora 20 times in my entire career in person. And yet there's thousands of images and terabytes of data that their camera systems gather. And uh, and yet there's observers that see the aurora almost every night that there's a clear sky. But it is a partnership, and that leads to new discoveries. There's two loaded terms, I think, in that definition, and it kind of biases back to that idea of observation and collection, just like the chat GPT sort of biased that a citizen scientist is somebody who sees something out in the field and reports it. But I think observation and collection are actually very, very broad terms, and I just listed some synonyms for them below. You don't just go out, take a picture of something or observe it or write it down. You are doing all kinds of verbs, everything from going out and actively chasing the aurora, capturing it with your cameras, doing the image processing to extract things. Maybe you'd had your settings wrong if you didn't know your material, your equipment better. But you're also maybe building and designing equipment or building and designing software or organizing with a group of people and collaborating and participating with your local astronomy groups. So observation could mean all those. And that term collected could mean how do you work with your data? It's very easy as a participatory researcher with a camera to have terabytes of data on a hard drive, but have you looked through it? Have you sorted, gathered? Have you collated it? Have you surfaced and filtered and done all the data collection stuff that we hope AIs can do one day, or large language models or image processing can do automatically? A lot of that anomaly recognition is a big part of the value I think a citizen scientist role brings to the collaboration. So I put together a recipe of what citizen science participatory research collaboration with the research community looked like, maybe in this instance. Um, and one thing that I was really thinking is, yes, you have local knowledge. I don't know if you can see my little mouse pointer. Like, you got to be in the right place at the right time. That's said in the definition of the Arctic's Handbook for Citizen Science in the Imaging for Science and Working with Scientists sections, which are a really good read. And yes, you have your technical knowledge about your cameras and your lenses and maybe your software and how you organize your imagery. But one thing you really bring is when you're familiar with those first two things, you bring the human power of anomaly recognition. You've seen hundreds of aurora nights, and you know when something's weird. And when something's weird, that's really the start of science, I think. It's having a curiosity and surfacing the weird, the anomaly, the thing that you don't normally see, and then using your community connections to reach out and be brave like that mouse before and say, hey, I think I see something weird and I don't believe it's a street light. So there are milestones in the process. Like, if you capture something and it seems strange, you do want to report it to some kind of community like Aurorasaurus for further investigation and choose your collaborators who you're going to work with and investigate more. It might just be the people in the chat that you have, say, an Alberta Aurora Chasers group or something, or it might be evolve into more than that. You're deciding who to continue the conversation with. And there's a process that starts to happen, and you're going to be involved in it. And that process is the scientific process, the research process. And it is a very specific process. It values careful consideration, background research, credibility, and careful observation and correlation. It's a very interesting culture, and it's not something you run into every day. And I think the research culture is something that is to be appreciated and respected, but at the same time, there's a lot of sort of foreign elements of it that you might all of a sudden be dived into because they have their own distinct domain-specific language and you don't know the acronyms, for example. And another big part of collaboration is that it's not just a handoff. It's not, I found a picture, you can see my post on Instagram, we're done. No, a citizen scientist very much is the steward of their data and their observation, and that data has to be presented and aligned with other instrumentation. Like, for example, a science camera has to be associated in time with the photo you took. You have to find out what direction you took it, what your camera settings might have been to determine some kind of calibration. Your role doesn't end by saying, I saw something weird. That might just be the beginning of it. And you want to be there for your data or your time lapse or your observation to make sure that uh, the relationship and the whole team that's doing research has what they need from your observation to tie it all together with the whole story of what all their instruments and previous domain-specific knowledge has. And finally, after all that, you also want to learn something. You want to be able to read the paper. That's why they have uh, a human, or sorry, what is it called? Not a human readable aspect, the plain language summary abstract. AGU, I believe, has that. And And yeah, that's a wonderful read too. It shows they're trying to reach outside of what the community that already knows a lot about that specific topic and is looking to advance at that next level and trying to bring new people into it. It's it's worth reading the paper, and if you don't see a term, uh, look it up, and it might start a kind of a spreading tree of learning about new things. And that's what for example, Liz did when we had the journal club, and we went through a paper and asked questions about it, and it was exploring the references in a paper that provided so much context and interest. And uh, so, as a citizen scientist, if you're a scientist, that means you're curious not just about your observation, but about what all the work has been done previously. So let's talk about a little bit about this observation and Steve. I first saw Steve in 2019 when I was in the Yukon. I was at 60 degrees geographic latitude, and just a day before kind of a storm condition, a light storm condition, and I didn't know what it was. I'd went to a talk about Steve, and they said, "Oh, it's a white arc." Um, that was all that was kind of understood at the time when I went to that particular talk in that particular venue. So I noticed this out of the corner and I thought, well, that's not really an arc. It's a bunch of wisps. They look like a bunch of racing sailboats in line. And there's these weird green things below it. So I didn't really focus on taking pictures of it specifically because it was there for a good hour or so. And I thought, oh, I'll get back to it because there's lots of other exciting things happening in the sky. But the curiosity starts to get you. It's like, um, if it's Steve, they always say it's over Calgary or farther south. How come I'm seeing it way up in the Yukon looking south? And if you do some trigonometry about the horizon, you realize, oh, this is probably at least 500 or 1,000 kilometers south of us. So that kind of makes sense. But then why isn't it a continuous arc? Um, and did anybody else see this at the same time? So that's when you reach out to the community. When looking back, I was wondering what time this was, and I thought, oh, did I set my camera clock accurately? I'm not sure I did because it tends to drift and you're traveling and you're cold and you forget to set the clock. So I can't even really say when this exactly happened or what direction my camera was pointed. I was pointing at all different directions, taking pictures of all kinds of things happening in the sky. And I caught it in the middle. What precipitated its beginning? What did it look like when it first started? I don't know. So I started asking myself, can I somehow record the whole sky for the whole night while I'm pointing other cameras around? And we'll talk, this analogy is, I think, not super accurate. There's always much more to it. But what is Steve, just briefly from maybe a citizen science or a lay perspective? And I think of it as like an incandescent light bulb, whereas the regular aurora is more like a neon sign in terms of their emissions. That Steve white line that we saw in this previous slide is kind of like the filament of a light bulb. It's more of a thermal process, and that's why they call it a continuous emission. It's like a light bulb where it goes different frequencies across a broad range. And regular aurora has those distinct colors, which can get mixed from different perspectives when you're looking up at the sky at an angle. But the emissions tend to be at specific wavelengths. So that's just an analogy. I'm not sure how accurate it is. Um, so going back to, what did I miss? I started thinking about making a portable all sky camera I could bring along with my aurora chases. And this was sort of done for just because I didn't want to miss out on the whole sky while I was looking around. I didn't want to be that person who just looks at the back of their camera when they should be looking at the whole sky. So this allows you to step away from your cameras and just lay down on a picnic bench or something and look up at the sky and enjoy it, knowing you're not missing anything. Um, and that was very freeing, I think, but also it sort of addressed some of the issues I had before, like this isn't time stamped. I don't know exactly when stuff happened, and I thought, well, that's not hard to integrate along with the camera to start sort of calibrating in location and time and letting it run all night, so I can go to bed at 3 in the morning and maybe miss something, but maybe not. Let it do the work for me. So this really was kind of like an art project, but also a project to help automate capture. And then it evolved into really bridging that research community and their instrumentation to uh, to what people capture when they bring a camera up north and start pointing it everywhere and taking pictures. There's a gap there that could be filled, and so that's how this Aurora project started with a portable all-sky camera. So 2 years later, I was in Yellowknife, which is kind of near the Yukon, but not really. The Yukon is halfway in between, say, Fairbanks and Yellowknife. But I was doing the same thing. This is like take two opportunity. I was using my regular camera on the left, and I was on a frozen lake because you can drive out on the lakes when it's that cold. There's ice roads everywhere, and then you get a good view of the horizon in all directions. And I had started a campfire, and I was talking with somebody else who was there, and I'd missed a whole bunch of things in the sky because I was enjoying the campfire and warming up. It was very cold. But when I wandered back out on the lake, I noticed a that same white arc again overhead. And I'd learned a bit about Steve from reading the papers, and I knew that it shouldn't be this far north, or knew, as well as somebody who isn't, I guess, privy to the exact data. I just knew in that Steve is supposed to be south, and it's not really seen up here. And on top of that, it's not seen during quite nights. There was a big storm a few days before, but that was a few days before, and it was actually a very quiet night, which is why I had a campfire. I didn't think much was going to happen. And but nonetheless, fortunately, I thought, well, I've got this Aurora camera. I'll put it out anyways, and it'll be taking pictures even while I'm at the campfire warming up. So even though my main cameras or my sort of artistic cameras missed most of the show, it still caught everything. And I knew there was something up with seeing it this far north. So you can see on the left a regular camera, and it missed a bunch. And the Aurora seeing the whole sky, and it was running for some time before and some time after this event, and managed to capture everything. So it met its goal of keeping me from missing out. Um, I was curious about why Steve was this far north, if that's what it was. So I took a page from The Simpsons where, what is it, Superintendent Chalmers says to Skinner, this time of day and located entirely within your kitchen, the Aurora Borealis. I don't know if you know that meme at all, but it's a Simpsons thing. And that's the quote in this social media post I made, I think, on Instagram. And I tagged some researchers to ask them, what's going on here? I've got more information if you need it. Uh, and Bea reached out to me through this particular channel and said, yes, there's something to talk about here for sure. There's a story. Let's start talking, see where the data takes us. And that's how the sort of story of the investigation really started. Um, I won't get too much into this because I want to hand it off now. But since then, I've tried to help with other collaborations, like by time synchronizing the Aurora, you can work with, for example, the Space Weather Timeline Viewer by Dr. Elko Dornbos, and you can look at your own instrumentation dashboards that you create with magnetometers and interplanetary magnetic field timelines, and it all lines up because it's time synchronized. And that's the importance as a citizen scientist to set the clock on your camera, for example, because now you can correlate with all these other instruments and leverage all of that and really be a part of the discovery. And you might find something by looking at the Space Weather Timeline Viewer yourself. So yeah, the tools are evolving. And because this is a collaborative environment in so many ways, this is a good opportunity to also thank everybody I've worked with in just the last year. And there's a partial list from groups to individual researchers to investigative teams to the Arctics group that's putting together the sort of outreach documentation, and then the people like Vincent and Donna who've been so generous with their time and enthusiasm to take the Aurora units out and capture the imagery you see on the left. Uh, None of that would have happened without the collaborations that are going on now. And you really do make your own luck when it comes to both aurora chasing and then what you do when you see something interesting and who you reach out to. So thank you to the entire community who's sort of bridged the gap if you call it a gap between research and citizen scientists. It's a wonderful sort of space to explore, and it's still an active exploration. Don't feel burdened by any terminology saying this is a citizen scientist and this isn't. It's an evolving definition, and you contribute what you can. And as long as you're following your curiosity and knowing what really motivates you, it's a great place to be. So yeah, thank you, everyone. I'd like to hand it off to Bea now about what happened after this observation.
Thank you, Jeremy. That was fantastic. And yeah, absolutely. You made us aware of everything that was going on. And I agree with you that I think it's curiosity for the aurora that brings us all together. So that's good. Can you see my slides?
Yes, thank you so much.
Yes.
Perfect. Thank you. So this is the title of the paper. I know that Liz, thank you so much for putting it in the chat and put it in the chat for you. So just to start, I'm going to say thank you to Jeremy because working with him has been amazing. And thank you to Laura and Liz for inviting us to give this presentation today. So the title of the paper is Unexpected Steve Observations at High Latitude During Quiet Geomagnetic Conditions. Need to move myself. But to make it short, it's actually Quiet Time Steve, as Jeremy called it. So I love that he used the same name. And that's how we have been calling it in the community, because it's relatively rare. So I'm going to explain you why it's rare. But to explain you why it's rare, let me tell you what we know about Steve. And this is something that you all know. This is the Lisa's paper in Science in 2018. So you have probably seen this picture a million times. This crowd is a crowd that I don't need to show you, Steve. I don't need to explain. It's the purple arc. But if we look at this plot, it has a lot of information, I know. This is luminosity as a function of latitude. This is data from satellite. The most important one is probably the velocity. So this is the velocity that the particles are having, also as a function of latitude. So the rectangle here, the red rectangle, indicates the time where Steve is observed, according to the high luminosity that we see from the curve. At the same time, for the Steve event in that paper, we saw extremely fast particles moving westward. And together with a very high electron temperature and a sharp density decrease. In the scientific community, we have known that signature that's called a suborbital ion drift. And it's very normal to observe it. It's typically observed during storm times, especially if we have a substorm. So these are conditions that we observe. But the relationship with Steve was very important for two reasons. For the very first time, SAIDs, or suborbital ion drifts, were related to an optical phenomenon in the sky. So that was absolutely new. And second, the velocities that we were seeing were extremely high. And when I say extremely high, usually we measure 1 or 1.5 kilometer per second. This was almost an order of magnitude more than that. It was extremely fast moving ions, very few of them, but moving very fast. And we didn't understand why they're moving fast. And I think we still don't understand why these particles are moving so fast. What is exciting these particles to these velocities? And when I say fast, they really move fast. So this paper by Carlos Martinez, he measured a Steve event that is observed here in this portion of the image, but also using the same SWIRM satellite, the velocities that we were observing were close to 10 kilometers per second, which is unheard of. This is extreme events in the suborbital ionosphere. If we go back a second, the temperatures, for example, this is up more than 6,000 Kelvin. This is not a typical temperature in the ionosphere. That temperature is what you find in the sun's surface. Yes, very few particles moving extremely fast, but being extremely hot. So until this day, we do not understand what conditions are creating these extreme circumstances. But for the SAID point of view, we knew that the SAIDs were related to substorm. If we go back to the literature, every single paper will tell you suborbital ion drift are related to substorms. And that's why the event that Jeremy found is so important, because there is not a substorm happening, and there is at the very end of a storm and everything is extremely quiet. So we went back to all the events that we had from the scientific data and extended the time period where we were looking at the DST index. I know you are extremely good at reading indices, but very quickly, what we have here is what we call the ring current index that usually tells us whether or not there is a storm. I know that when you're going out to observe, you look at this index or something similar to that. So what we found with these events is that we usually observe it during storm, and those storms can be small, medium, or large storms. So on average, we usually have things happening. The relationship with substorms was even clearer. Whenever we see substorms, we see Steve. So for the observation, for Jeremy's observation, and he tagged me in this and I was very confused. So we came back to all the scientific data and realized that we have also observed it in one of the scientific instruments. And this is the Yellowknife T-Rex RGB camera from the University of Calgary. You are seeing that the auroral oval is very active at higher latitudes, and Steve propagates from east, that is from the right of the camera, to the left of the camera. This lasts about 15 to 20 minutes. It's very short living, but it's very clearly observed in the camera. This camera initially was not part of the T-Rex system, was kind of an extra camera that they had deployed there. And now the Yellowknife camera, I think because of these events, gained its place within the system. In terms of the latitude, and this is what Jeremy was telling you, so we did the whole statistics for all the events that we knew, and we found that for Steve, we typically observe it at 60-degree magnetic latitude plus minus 2 degrees. In my mind, I usually call that Steve's sweet spot. If you have a chance to see Steve, it's going to be within these latitudes. But of course, that's not always the case. The event that Jeremy found is actually about 10 degrees forward of the typical observations of Steve, which was interesting and rose a lot of questions. If it is at 70-degree magnetic latitudes, is this within the auroral oval, or are we seeing this below the auroral oval in the region that we call the subauroral region? That's important because the topology of the magnetic field is different. So the interactions that the magnetosphere and the ionosphere are going to have are also different. And you have seen this. This is from the paper. This is a beautiful data from Jeremy. And this is what started all this discussion. So in this case, west is going to be to your right. You see that the aurora is active. However, the main signature of an auroral substorm is not happening. And that is the poleward and equatorward expansion of the oval. When we look at the indices are completely flat and nothing is going on. So for this event, we have observed a Steve event that it's a very high latitudes and no substorm, although the oval is active, but it's not moving equatorward. So we were very lucky to not only have Jeremy's data, the Calgary data, but we also had swarm satellite data, the two of them, swarm A and swarm C, passing through the same latitude at about the same time, just slightly westward of the observation, which is okay because since Steve or the CID propagates from east to west, if we're observing something in this location, satellite slightly west will catch the motion of those particles. So this is very simple. Don't get scared. This is velocity, density, temperature as a function of latitude. And latitude is increasing to your right in this case. So we do see a fast flow, very narrow and very fast. This is more than 4 kilometers per second in a region of low electron density and high electron temperature. So we are seeing for one of the few times that I could find in the literature, a subauroral ion drift at 70-degree magnetic latitudes. And this was important because many of us have used the term mid-latitude, which is usually below 60 degrees, interchangeable with subauroral. And right now, I think they're completely different because during quiet time, of course, the subauroral region is way at high latitudes. So swarm A and C were showing us that we were observing this SAID, this extreme SAID related to the Steve observation. With other data, from particle data, we also learned that we were in the subauroral region, so below all that precipitation. Things that we don't understand is why, if the auroral oval is so active, why it's not expanding in any direction. One thing that we found out is that and this is a paper by Toshi, a subsequent paper by Toshi, and part of our paper too, because we tried to calculate what was happening with the magnetosphere. The magnetosphere is very inflated. So what creates those conditions and what makes, if there are not substorms, and this is at the very end of the storm, what is driving the ionosphere? And I think that's the most important questions that we haven't been able to answer. So in summary, we have observed a quiet time Steve that was detected in the absence of storms and substorms. So probably if you were looking at the indices, you would not even have been outside. But since Jeremy was so up north, he knew that he would observe aurora, and he didn't even see only the aurora. He also saw Steve. The auroral oval was in this event confined a very high latitude. So this is 70-degree magnetic latitude, a Yellowknife, Canada. So very, very north. And we're analyzing what are the magnetospheric, ionospheric conditions for this type of events. We don't fully understand the magnetospheric condition, but more than that, we don't understand the fast response and the extreme response during these quiet times of the ionosphere. We definitely need more events to really understand the physics behind this. And these are the two papers that Toshi and I published last year with all our collaborators, of course. So Liz reached out to me this week and asked if we could give an update on Arctics. And Arctics is the Auroral Research Coordination towards Internationalized Citizen Science. And this is a group that has been established for a short period of time. They gave us like 1.5 to 2 years by the International Space Science Institute, that we call it ESI. And this is a working group. So the way it works is you write a proposal to study something that is in the portfolio of ESI. And you send the proposal to them, they evaluate the proposal. And if they like what you're proposing, they tell you, okay, bring this group together and make progress. So we had the chance to do exactly that. And we had our last meeting of the 3 that we got to get last week. So that was our last meeting. And right now we are working on how do we move this beyond only Arctics? How do we make Arctics 2? And the idea of this group was exactly what we have been doing for all these years, especially since Steve. Citizen scientists and photographers have such a knowledge of the aurora because you have been looking at it consistently, almost night after night. Your eye is very trained, as Jeremy said, to find something that is unusual. And that's why you pause, because it's very unusual. So all that for us becomes data and becomes a possibility of finding something new, the possibility of new discoveries. So this is actually created by also AI. So last week I realized we didn't have a logo. Neil Sauer said this is not a logo, this is a sticker. So this is something in between. And Vincent and I went on Copilot and decided to, I think I created half of it, but then Nora Partamis had a video of a polar bear eating one of our all-sky cameras. So that's a polar bear eating the all-sky camera. So in the Arctics working group, this is led by Maxime Grandin, and I'm his second in command. So the two of us wrote the proposal, invited a group of people. Many of you are here today. And this is a whole group. So in the working group, we get to invite about a maximum of 15 people. But that's what we call the core team. But apart from the core team, we also have a large group of collaborators. And the large group of collaborators are scientists and citizen scientists. And the same with the core group. You can see many familiar faces here. One of the challenges that we had is Easy invites us over. We work a whole week together, and Easy covers the hotel and the per diem. But we have to figure out how to pay for flights. So for scientists, that's easy. We usually put it in our own grants and we go. But it was challenging to find a solution for the citizen scientists. So, for example, Aero here in the picture, he got a fellowship for the last meeting. Vincent got funding from EASY itself, and Donna, Chris, and Neil were sponsored by the University of Calgary. So Eric Donovan and Dave Knudsen paid to help us bring the citizen scientists. So this is definitely a team effort to put this group together. And this group has been extremely um, it has given very good products. And some of those products are, for example, the field guide and the handbook that Jeremy told you about. But we have also worked together, and this is kudos to Katie Herlingshaw from the University Center of Svalbard, who found this opportunity. There was this new commercial space flight mission from two, and Katie created this project within this mission that was for the astronauts to capture the aurora and capture observations that we could use for research. We're still waiting for that data, but Katie is hoping to have a holistic view of the aurora where we see it from above and where we see it from below, not only with our scientific instruments, but also with citizen scientist data. So if you were outside taking images that between April 1st to 4 this year, please report to Skyward and or let us know or contact us. I'm very happy to talk to you, to put you in contact with Katie. Katie is fabulous. So she's a wonderful person to work with. And as I said, the field guide, Katie printed physical copies for us, but not only for us, those physical copies also were taken to space. So here is one of the astronauts showing us a field guide in space. So we were very excited to see the work that we all as a team put together in space, actually. So that was super exciting. The other opportunity that I also helped to lead is the STEEP workshop. And we have planned the first STEEP workshop for October 16 to 18 of this year. And it's going to be in Fairbanks, Alaska. So as you probably know, we are 5 main organizers. Phil Erickson is our leader here. So the way we have been organizing this, and this is why NSF logo is over there, the 5 of us wrote several proposals, or at least 2 proposals, not several, 2 so far, to request funding for NSF. So right now we can bring the citizen scientists to work together with us. We pay for the flights, we pay for the food, we pay for the hotel, and pay for the transportation with the money that we get from NSF, and make this discussion about Steve and keep moving the work forward. But now this year is even more special because we actually have the local organizing committee, and we have Mark on the Don Hampton and Vincent that you know very well as local organizers of this meeting. So right now we are 8 organizers of the meeting. So as you know, very briefly, the very first meeting was virtual because of the pandemic, but then we met in person in MIT High Stack. So although we have funding, of course, the funding is never endless. So we have funding to bring certain amount of people, and we're hoping that we can continue doing that. Nonetheless, the meeting is hybrid. So if someone wants to join this meeting and can spare the time, join us online. We usually put this in the website, and I'll be happy to pass this information once we have it to Liz and Laura. And I think that's my last slide. Thank you.
Great. Awesome. Thank you. Let's see. Thank you both. Would love to take questions. I think there's one question in the chat about, excuse me. Vincent, do you want to read your question? Thanks.
Yeah, sure. So my question was, and this is for Bea, I think, but I guess Jeremy or anyone else can also answer. But What kind of substorm does there need to be to produce an SAID or a Steve? Because there's a lot of substorms, but then we don't see Steve all the time. So that's just my question.
Sorry, I missed my control for a second. That's a good question. So one of the things that we have realized is that since this is research that was done in the 70s, we were looking at between the 70s and the 90s. So very, very limited optical data. So I don't think the substorm related to the SAID has been characterized. And that's definitely an open question. And that's something that we have been working on. Also, we don't fully understand, and sometimes this feels like a bit of folklore. We don't fully understand what's the physical mechanism for when you have a substance, you have many injections coming from the tail into the closer to the inner magnetosphere. So what is happening in that transition region? The region is very complicated, as we talked last week, because you have an interaction between the tail of the magnetosphere, the inner magnetosphere, the ring current, the ionosphere. So it's a very highly coupled system. So I understanding and decoupling all the physics that is happening there, it's going to be difficult, but definitely the first step will be characterizing SAIDs that have subsum that have SAID, subsum that don't have SAIDs. For Steve, I can tell you that the answer is relatively easy. We took all the subsums that we had from the Supermag data set, so those were like 16,000 substorms. And when we compare them with the substorms for Steve, sorry, I'm very tired at this midnight where I am right now. When we compare those two, we realize that the expansion phase, so the phase where we have most of the injections from the magnetotail, was longer than for regular substance. So that potentially is giving us an idea of an energy budget that is slightly larger for those events.
Thank you.
I meant to say earlier, but also just thank you so much, Bea, for joining us when it is so late, and to Michael and Hannabella as well. We appreciate y'all staying up with us.
Mhm. Jeremy, do you want to go ahead and ask your question?
Oh, sure. Yes. Uh, yeah, it's so wonderful to see sort of like the investigation and how all the satellites are tied in and the other cameras and how there's so many different kinds of sensors and senses that go into doing these discoveries. My question would be for citizen scientists and participatory researchers in the future, how could they contribute to future Quiet Steve investigations, whether that's looking, for example, through their old archives from when they were up north, or maybe how they could make sure to look out for it on future trips, or maybe there's some online databases they could help data mine. I'm not sure exactly, but how could we help with the investigation? Thank you.
So all of the above, we need all the data we can get. So if you have been in the northern, like more high latitude staking data, and you have it in your hard drive, and you happen to go through it, pay attention, because you might have a Steve event. If you're going to the north, I always said, people always ask, why didn't we realize that Steve was there if we have been observing the aurora consistently? And I said, well, the aurora is so dynamic that we probably got distracted just looking at how beautiful the aurora was, while in the back, while we were not looking, Steve was dancing, and we couldn't capture it. So if you're looking at the aurora and you're higher at higher latitudes, sometimes just look back and point your camera and see if you can catch a Steve event. Um, but yeah, definitely. We need all the data. And although, as you said, there is so much data in this, there are so many instruments in the field, it still doesn't feel like it's enough. I still have gaps where I wish there was a camera, I wish there was a satellite. So your data and your observations are extremely valuable.
Definitely, definitely. Could I ask a question about this particular observation? Was it fairly short, this, Steve? And secondly, did you look at like just the like Yellowknife magnetometer, or if there were any like local or very small, like the possibility of the larger global indices not really registering, but maybe something very small was happening locally.
So, can you remind me the first part of the question? Sorry. I'm literally asleep. I woke up at 6 today.
I'm sorry. You can pass on that question. We can do
No. I know the answer, but I just don't remember.
that.
So you asked about the first part
It
was
was a little like it was only like 15 minutes or something. Am I?
yes.
Yeah.
So it's a very short lasting Steve. And one of the things that we did with Toshi is we look at more events, quiet time Steve events. And in his paper, he has two or three more observations. And we consistently observe that the Steve events that we saw for during quiet times are more transient and fainter too. So they're not as bright as the typical Steve events, except for the one that Jeremy caught. All of the other ones are very faint. And the other one for the magnetometer data, yes, we look at all the magnetometer data and you can see magnetic field perturbations in Yellowknife. But when we plotted all the ones equatorward, several of them, there is nothing going on equatorward. And actually, in the paper, we calculated the total electron density with the total electron density, the electron density distribution, and we can see the high density of the plasma pulse extended all the way to 70-degree magnetic latitude. So this is a very, very inflated magnetosphere. Toshi took his events and mapped them to the ionosphere. And I think he calculated that the plasma sphere has expanded up to 11 Earth radii. So it's a very thick magnetosphere.
Yeah, that's cool.
Yeah,
I have Miss Toshi's new paper on this, and I'm struggling to find it.
I can come back to the link. Wait, let me.
Oh, thanks.
Yeah, I have it here. So
Hi,
that's my
Liz.
computer.
Regarding the transient nature of this observation, in my tiny bit of experience seeing Steve, this one was short, which is why I almost missed it with my other cameras, but then was glad to have the all sky camera. On reviewing the data when I was working with Bay on it, I looked through the remainder of that night on the all sky camera. We did see, I think, an hour later, almost exactly, a very faint Steve kind of re-emerge, or what I thought was maybe it was so close to the green auroral arc, I thought I should just point it out. And I believe that's mentioned in the supplemental material of the paper, but I thought it was weird. I thought it would show up once and then go away, and for it to reoccur an hour later. And I think that was coincidentally during another satellite pass by Swarm as well, which was fortunate.
Yeah.
So not only was it short, but I think it might have happened twice, or maybe it went invisible and reappeared. I don't know. That's beyond my understanding. But uh, that's why it's always worth going back and checking your hard drive, as Space said, if you never know what's in there until you start looking a bit further.
Other questions? Tanya's looking at solar wind data and magnetometer data. It's very interesting. It was at the end of this a small storm too. And maybe not Steve's prior to that during the storm.
Yeah,
Um,
I don't think we saw any Steve during the storm or in the main phase. And it's the same for the Gannon storm. There are no reports of Steve, and that's puzzling. So it appears to have an upper limit for the magnitude of the storm that we could see Steve during.
yeah, very different size storms, but yeah, it's interesting. Um, all right. Oh, we're at 3 o'clock here. Let's see. 3 o'clock and bedtime for some people. Whatever time it is, it could be bedtime. Yeah.
Yeah, thank you so much again for staying up with us when it's so late over there. And enjoy your cheese for those of you who are about to enjoy your Gruyere. May you enjoy it more than the crows did.
we'll enjoy looking at these papers. Those of
Yeah.
us without cheese, at least we have cool Steve papers, and really appreciate all of the sharing, and would love to keep chatting. So you all are welcome anytime.
Yeah.
And thank you so much, everybody, for, I mean, the whole Aurorasaurus Ambassador project has been about collaboration, and I like that we got to be a positive example of how that can work. So this is like sort of like winning the Aurora lottery for me. It's been great collaborating and working with Bea and learning so much about the process of how science works. That was so revealing. It was like a behind the scenes of how these papers come together. And it's just wonderful working with a community like this. Thank you.
Likewise, Jeremy, back at you.
Mhm.
Pleasure working with you. And thank you so much again, Liz and Laura, for the invitation. This is always fun.
Thank you. Yeah.
You. Yeah, we're just so grateful for all of y'all and the ways and the different perspectives that you bring to all of this. That it's so wonderful to be able to look at this in different ways.